afternoon or good evening, depending on where you are in the world. Welcome to today's final session on regulatory compliance and ICS security, sponsored today by Keyfactor. First off, it'd be great if you could just tell us who you are, where you are in the world, in the chat. Just give us a feel for who's joining us. And while you do that, I'm just going to cover a couple of bits of housekeeping. So it's going to be an hour-long session. I'll be introducing the topic first, and then introduce you to our guest speakers, of course, and we'll going to be trying to get as many insights from them as possible. We'll also try to leave some time for questions at the end. So please do get your questions into the Q&A function of the tool. Don't use the chat. Please use the Q&A function. It just makes it easier for me to find them, and it makes it more likely that you're going to get your question answered if you do that. So please do that. Don't wait till the end. Once a question comes into your head, get it in there. And as I said, we'll try and get to it by the end of the session. All right, so this session, regulatory compliance and ICS security. Obviously, industries are facing a lot more scrutiny, a lot more stringent regulations, and they need to ensure compliance while maintaining robust security measures. Is becoming more important every day. And we're going to be providing insights into that, or rather the panel are. Latest regulatory frameworks, compliance strategies, and practical solutions for protecting ICS environments. So they'll be giving their views on integrating compliance into security postures, leveraging advanced technologies to meet regulatory standards, and also preparing for the future regulatory trends. And there is a boatload of regulation coming, as I'm sure most of us are aware. To anywhere, whether you're in Europe, Asia, America, it's all coming. So we want you to. The goal of that is really to help you try and stay ahead of this wave, because you want to be ahead of the curve if at all possible, and making sure that your ICS operations are reliable, resistant, and compliant. So with all of that said, let's introduce our special guests. First up, we have Ellen Bain, who is SVP of Global IoT Strategy and Operations at our sponsor, Keyfactor. Ellen leads the go-to-market strategy for Keyfactor's IoT business, focusing on digital identity security solutions for the IoT device manufacturer market. She's very passionate about IoT and helping customers establish strong security implementations for the life cycle of their overall IoT systems. She has more than 17 years of experience in leading new product development with a focus on IoT connected products. And she has held many leadership roles in product and engineering at General Electric and Sky Technologies before she joined Keyfactor. So delighted to have you with us, Ellen.
Thank you.
Next up, we have Jack Velozovitz, who is CEO and CTO of Cyberus Labs. He's a serial entrepreneur and co-founder of Cyberus Labs, which specializes in securing IoT platforms in critical infrastructures even. He has numerous patents in telecoms, VLSI chip design, and cybersecurity, and he has a BA in electrical engineering from City College of New York and a PhD in aeronautics and astronautics from MIT. Thank you very much for joining us, Jack. And next we have Sander Rodmanson, who's head of the internal startup for cybersecurity for OT at Siemens. He began his career in 2005 at Siemens in the Netherlands as a technical consultant for industrial automation networks, focusing on industrial VLAN, and then took on a number of roles at Siemens, both in Germany and in Canada, is where he was for a few years. Then he came back to Germany and he took over responsibility for the product portfolio for industrial 5G, industrial VLAN, industrial routers, and the Cinema Remote Connect management platform for remote access. Today, he's leading an internal startup specializing in OT cybersecurity, and he's responsible for Synex Security Guard, which is a cloud-native solution for detecting vulnerabilities and attacks based on risk assessments even. Many thanks for joining us, Sander. And finally, a few words about me. I'm your moderator. My name is Hamish Mackenzie. I'm a former IDC analyst. I've been running my consulting business here in Munich, Germany since 2006. I walk along CEOs, founders, and other senior executives, helping them improve their growth efficiency primarily and positioning, things like that, and also helping them become more effective in their roles by helping them get out of day-to-day operations and focus more on strategy and evangelizing the business and their solutions. So that's me. If you'd like to know more, please look me up on LinkedIn. I'm pretty sure I'm the only Hamish Mackenzie on LinkedIn in Munich, so it shouldn't be too hard to find me. With all that, quick reminder, if you have a question, please get it in the Q&A function, and we'll get to them as many as we can at the end of the session. All right, so with the intros done, let's get into it. And I like to try and start these sessions with a bit of context. And I wanted to come to you first, Sander. If you could just try and explain to us in a nutshell, why is cybersecurity regulated in the first place? Why is there need for all this new regulation that's coming on stream?
So to put it quite simple, cybersecurity is an important topic, but it really doesn't bring a company revenue itself. So it's only protecting your factories, it's protecting your IT, and this is where people need to be taking this seriously. And there's not a real incentive to do this. So therefore, putting regulations in place, making sure people start taking care of protecting the important assets we have, like water treatment plants, energy suppliers, utilities around the world, but also car manufacturers, pharmaceutical companies, and they need to be enforced and very often to take cybersecurity as serious as they do. I'm thinking about creating a redundant network for a company, for a factory exactly. So this is where we really need to make sure to name some key numbers. That 70% of the companies, 70% of companies with manufacturing are attacked on a yearly basis. And if such an attack is successful, we talk about possibility on average to have a 24 days of outage before they're up and running fully again. So these are some numbers that we really need to help and stress that take cybersecurity seriously. And I'm happy that governments and Europe, for example, are taking a stance on this and putting legislation and directives in place.
Yeah, absolutely. And it's important not to forget that those 24 days equates to usually millions and millions of dollars in lost production and all the rest of it. So critical issue. And in the last session I covered, we were talking about how that means exactly those facts that you're talking about mean that it's becoming more and more a board level issue as well. It's not just a techie topic anymore. It's really an important issue right at the top of every organization that has this kind of critical infrastructure. All right, thank you for that, Sander. So Jack, I wanted to come to you now. Maybe you can give us a snapshot of the current state of cybersecurity regulation, because there's a lot out there. So maybe you could just give us a snapshot and how that impacts the OT world in particular.
Sure. There's been a lot. It really started with consumer protection and privacy concerns and loss of data. And GDPR was the lead piece of legislation that came out of Europe. Europe also established something called ENISA, which is, let me see, I'm just going to read the whole name of it for you. It is the EU Agency for Cybersecurity, and they are tasked with both enforcing and suggesting new regulations for cybersecurity, which then the EU Parliament has to pass. And a lot of the initiatives for cybersecurity really come out of the EU, and there's been the General Data Cyber Protection Act, Cybersecurity Act, and then the MIS Directive 2, which really specifies it and narrows it down a little bit more. And a variety of other regulations are coming, both in Europe and now the United States has gotten into the act really since maybe 2016, 2017. There are different regulations in different states, California, of course, leading the way. And there are a lot of government regulations now in place that affect procurement for government products, especially in IoT and OT. So there's really too much there to mention, because there's a new piece of regulation every day. And there are then downstream are compliance requirements, right? Because then there are compliance protocols which require you to comply with a variety of legislation that is always changing, right? So it's not an easy task, but it's way overdue, because as Sander mentioned, there is no profit to be made out of cybersecurity mechanisms being put in place. And without some sort of a financial penalty, there will be management decisions that are made to, and that this is the way things have been going till now, is to just forego cybersecurity because it's an unnecessary expense. This changes that equation, and it's way overdue, especially with the advent of IoT and OT.
All right, and I just wanted to ask you actually just as a supplementary thing. So given what we have now, is it already pretty robust, or are the regulators kind of playing catch up a little bit, or how do you see that?
Well, as always, legislation lags reality by years, if not decades. So no, it's far from robust, and more importantly, it's disorganized and confusing because it's changing all the time. There's different states in the U.S., and there's a gentleman by the name of Jim Dempsey who runs Stanford Security Center, and also works with Berkeley, who I gave a session with, and he went through all of the regulations and how they impact industries. And frankly, it's very easy to get lost. It's attorneys have to be on top of it because it's a changing landscape. But it is behind, and at some point it has to get organized, consolidated, and easier to implement because consumers keep getting lost in the maze. But I think we're moving in the right direction, but I think it's a disorganized world out there.
Okay, all right. Well, right direction is good, I guess. All right, so Ellen, if I can come to you now. So in terms of what ICS practitioners are actually doing to secure their systems, can you talk a little bit about that within the regulatory context?
Yes. Yeah, so kind of as the other two panelists have already spoken, the current state of where we are is that every day more and more devices from a variety of manufacturers are being connected into our corporate networks, whether that's within sort of an office or enterprise, or in the factory, or in distribution, or more of an OT use case. So what we've been talking about and what we've been seeing is companies trying to create a security framework where these disparate devices can be, first of all, identified and trusted and secured. And so what I'm seeing people doing, and part of what my business is creating secure device identities that are certificate-based. Digital certificates have been used for years in enterprise IT for websites and authentication. And so we're seeing that, and the framework of PKI being able to, you're starting to be established in industrial environments. So that's basically the basis of establishing trust. So you have some certificate authority, which is an entity that is, first of all, owned and managed by your company or your factory, right? And then that is the valid and trusted root of everything. So I am seeing this starting to be adopted and implemented and pivoted over. But I think there's some things around it. It's not the same as IT. I think we're going to get into that a little bit, perhaps. We have to optimize it for factory environments. We have to be able to have the right policies and practices around that still keep the number one goal of an operation, which is to keep either producing product or producing services and producing revenue, right? So we don't want security, like we were saying, to slow any of these things down. We have to integrate it and sort of build it into the design and the overall architecture of what we're deploying. So I am, again, seeing modern factories being able to, they're setting up these new and complex systems and machines using PLCs, HMI, and gateways and things like that, but putting security in them so that they can be able to securely address these endpoints so that no one can interrupt operations or change what's being produced, or just have access into the network via some of these OT type devices or control systems. So yeah. I'll pause there, but that's kind of what I'm seeing.
Yeah. Okay. Good. No, that's really interesting. And that's what our audience is always like, is to get a bit of an insight into what's happening actually out there in the real world. But you kind of touched on that a little bit in terms of the OT IT dilemma or dichotomy, if you like. And I think it's true to say that there are some examples of manufacturers and other organizations who think, well, hang on a minute, whether this is based on a lack of budget or a lack of resources, lack of skilled people, well, we've got all this IT security. Why can't we just, kind of apply that, tweak it a little bit, and put that into OT. So Zander, maybe you can talk a little bit about why can't we just use the same tools and processes in OT that we use in IT?
So a simple question for you, Amish. How often do you update your PC? Or software on your PC?
Every time a new OS comes out.
Every time when a new OS comes out. Every time. I said most likely, I'm not sure you're using Windows or Mac, but Microsoft, for example, has their patch Tuesday. Typically, everyone supplies updates the Wednesday after. Imagine in a manufacturing location, a supplier gives you an update like we do. We for example, push out security advisories every second Tuesday. We copied that from the IT, so there is some good things there. Imagine we tell customers of us to update all their equipment every second Wednesday of the month.
Mm-hmm.
For some manufacturers, this might work, but if you're, for example, a utility, or if you're working on pharmaceutical products which have long lead times, or because they have a longer production process, and someone decides to update now, you probably lose a lot of money. You have a production outage. I mean, the 24 days sounds bad, but that is also a bad practice. So you really need to plan those things. You cannot just say, let's just update now because there is something critical. You might want to put other mitigation actions in place. That's why when you look at security advisors from the different vendors out there, we not always just have a patch available. We also have mitigation actions in place. For example, like, hey, this firmware version will help you. But you can also just turn off Telnet or close this port or add a firewall in front of it. So there is a less intrusive solution to do this. No one is ever going to tell you if you were in home office, oh, you can keep your PC as is, just put a firewall in between. And that's not going to happen. They really want to update your PC, just as a real life example. And then there is also this topic within industry. Many of the devices are very, very old. I think on average we change in a normal company environment, every laptop gets changed every 3 to 5 years. Our switch or networking infrastructure is probably changed every 2 to 4 years, depending on what kind of vendor you use and if you are expanding currently. In OT, we get calls at Siemens from customers who are using equipment that's 15 years old. Here on the top of my shelf, you see an access point we launched in 2004. There's still machines out there who rely on them. So we end of life them in 2012. People can still get spare parts for those. It's a whole different thing as what IT is. Therefore, the mechanisms are completely different. Processes are different. Choices are made in a different way. And sometimes updates can only be made once a year when there is a shutdown in the factory. So there's some of the reasons why there is different processes, and there is also a need for different tools because you can't rely on the same tools.
Okay, good. I think that's very clear. All right, so just to finish off the context section of this, I want to zoom out a little bit because I think Jack also has a bit of a broader perspective on why poor cybersecurity is not just important for individual manufacturers, but it's actually an impediment to the progress of the economy and society as a whole. Can you talk a little bit about that, Jack?
Sure. We started out thinking about kind of the broad context of cybersecurity because the statistics for IoT are just overwhelming. There are billions of devices being introduced every year with no cybersecurity built in, and I think that what that is creating is kind of a penetration of OT and IoT devices in the world as a whole. So pretty much all the new critical infrastructure that is being built today, for example, like all of the green energy projects that you hear so much about, all of that is based on OT and IoT types of technologies. It's all communicating through wireless links because that's how we build systems today. And when you have a cybersecurity risk that comes along with that technology and could potentially shut down an entire operation, which is critical to some sort of infrastructure like a power grid or like water distribution, then the downstream consequences are disastrous. And so the investment community has actually already recognized that. And if you look at the bond rating agencies and some of the investment banks looking at the top line risks in making investments in new enterprises, cybersecurity is either the top or in the top 3. Okay, so if you have a decision being made for an investment or a bond issue based on the fact that somebody hasn't satisfied all of the cybersecurity protocols, which are even now nebulous at best, then the outcome of that is there is no investment made into a new enterprise. Critical infrastructure does not get built. All of Joe Biden's plans for creating new green energy projects, which are very much incentivized today in legislation, those could go nowhere because it still needs private sector investment, right? So you're facing that kind of danger, and like, for example, I think we have someone from Moody's in the audience today. I believe Liline Carvalho, and she would tell you that if you don't have your cybersecurity locked up, say goodbye to your investment. And if that's going to be the outcome, then we can't move forward.
Yeah, no, absolutely. She was actually on my last panel that I did a couple of hours ago, and she was, some of what she was saying was exactly aligned with that. So yeah, all right, thank you for that. Can I ask our technical wizards in the background? We have one poll question that we'd like to ask you in the audience. So guys, could you put up the poll question? There we go. So if you could just give us your insight into that. It's interesting for us to know, what stage you're at on your OT cybersecurity journey. So thank you for doing that. In the meantime, I want to get into the weeds a little bit more about the challenges that we're facing in terms of getting cybersecurity into good shape on the OT front. So Jack, if I could just stick with you for a second, could you just give me your opinion on what is the single biggest obstacle to better cybersecurity? I know that's a difficult question to answer because there are so many, but if you could just pick on one obstacle that you think is particularly important.
That's actually a very easy question because I think the biggest obstacle is the short-term profit motivation, which is mandated on public companies by Wall Street, right? So if you're looking only at the bottom line, and your focus is, your horizon is no more than the next quarter, then you're kind of stuck in the mindset of, well, why would I create this expense for myself when there is nothing bad that's going to happen within the next 3 or 4 months, and that's where my bonuses get paid out, right? So it's really the way the corporate world is being run right now, and what is going to fix that problem is the fact that there is a real financial downside because of regulations and because of sort of more familiarization with what could potentially happen if something goes wrong. And one example I would offer is kind of a classic scenario now is what happened to Boeing, right? So Boeing actually emphasized profits, and they actually moved their offices from where the engineering was being done, which was in Seattle, to Chicago, which is where the investments were being done. And then along with that came kind of a single-minded focus on making sure that shareholder value is being maximized, and that is the focus. And you can actually trace back a legacy of poor decisions being made on the engineering side because of the fact that it didn't satisfy management goals for maximizing profitability. So that is the single biggest enemy of cybersecurity, and the single biggest friend is now the ongoing development of regulations and compliance requirements.
Okay, so that's going to drive change. I mean, there are obviously other challenges as well in terms of just because they decide to do something about it doesn't mean necessarily that there are the people available to be experts, enough experts to deal with a lot of these challenges. And so then they're obviously probably going to be a role for AI in some of this as well. But I think that's a fair point. Let's get into the weeds a little bit more about particular policies and procedures. Then, Ellen, if I can come to you, what are some of the specific pitfalls related to that lack of proper policies and procedures within organizations when it comes to security?
Yes. Yeah. So the OT realm, where you have operators sort of navigating very complex processes and systems and lots of different things coming together, I think two things that we have to ensure is, again, this sort of secure communication, oftentimes over protocols like MQTT, OPC UA, and just making sure that any data that's going across those is in a secure channel and it's confidential. So it's assuming you want to achieve that secure communication. And secondly, you want to be able to authenticate every one of these assets and endpoints that's within the OT environment, prove that they're legitimate, prove that 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 it's something you should be trusting, that again, it's either a vendor system that you've brought in or something you've built. Again, so assuming you want to do these two best practices, these common use cases, the pitfalls that you're asking about is, I think, really around the policies and procedures to implement consistent practices across all of these different things. Oftentimes you have multiple sites, right? You could have manufacturing in a bunch of different locations. You have vendor processes or sub vendors, sub-tier suppliers, and there's all of these software systems that are being deployed, and you have to make sure that you have the same practices across all of this. Otherwise, any one of those can have an inconsistency leading to a security gap. Then specifically around the authentication piece is making sure that you have a way to issue, in my case, certificates to these things, and also revoke them, because you want to be able to not put an identity on a device and have it live for that 15 years or the 20 years of the asset, but create a policy that allows you to revoke and then reissue, re-enroll. And so I think this is very important when it comes to the whole post-quantum computing conversation. We talk about this a lot with our customers and partners about the encryption that we're using today, how it can be cracked when post-quantum computing and additional capabilities around that can crunch these numbers and break these algorithms that we're putting in our crypto that we use, this sort of classic crypto today. So having policies to be able to revoke, reissue, and then rotate, I think is very important, whether it's encryption that we're using right now or getting to this state where we have to have something stronger that has been classified as post-quantum ready crypto and can't be hacked and can't be broken into as easily. So again, I think it's around that. It's having the policies and the standards, and then having some real practical ways to be able to maintain the security over time, because it's not a static thing. It changes.
Yeah, it's constantly evolving, and I know Jack will probably have some views on the quantum aspect as well. And I'll come to you again, Jack, in a minute. Before I do that, Sandra, I just wanted to come back to you again, and because you've got a lot of experience in dealing with these real world challenges. So what are some of the biggest challenges in terms of securing IT from your perspective?
I think if we're talking about OT, and I saw one of the questions where OT stands for, indeed, it's operational technology. It's the equivalent. It's the opposite of information technology. Just to make sure we've answered that one early on. So one of the big challenges is people. Because if you look into a factory nowadays, you walk in a random one, you ask for someone to explain you every nook and cranny in the factory, you're probably getting a very experienced person in front of you who knows everything. And then when you talk about cybersecurity, he's like, oh yeah, I don't know so much about that, but I can tell you where that screw is located. And this is one of the challenges we have. How do we get the people who are very familiar with OT technology, PLCs, controllers, drives, motors, mechanicals, how do we get them up to speed of understanding how to handle cybersecurity? And how do you add that workload on top of someone who's already busy keeping a factory running anyway? And then you have things like vulnerabilities coming out there. Did you know this year they expect 35,000 new vulnerabilities across IT and OT? 35,000 new possibilities to get access or to a system by someone who's not allowed to. You need to safeguard yourself against that, and that's a lot of work. So nowadays, people actually print out a security advisory, which is a stack of papers. I think the longest one we have is 52 pages at Siemens, listing all single products. People go through them, they list them, they see them, it's like, okay, did I ever bought this product over the last 10, 20 years? Then a secondary person is going to look at, oh, are we still using it? And then a third person is going to check, are we running it with which firmware version? And the fourth person is going to decide if it's necessary to make an update. And some of the companies we speak with say, oh, this is a day of work just for a single security advisory. Imagine having a couple thousand to take care of. Then we have a lot of different kind of devices from, I think if you look at an IT environment, we have network gear, we have laptops, we have cell phones, maybe a tablet here and there, maybe some office equipment, which is connected like a projector or a TV nowadays. But if you run into a factory, you have 5 different suppliers of machines or production lines. They use 5 different vendors for their controller. They use 5 different vendors for their HMI systems. They might have a different vendor for the network gear. You need to manage that all in one place because you want to safeguard your factory. And those are the biggest challenges I see at securing OT. It's a very diverse ecosystem.
Yeah, absolutely. All right, thank you for that. I just wanted to come back to Jack now. You obviously pointed out that the driver of more investment and more focus on this within these organizations is the new regulations and compliance. But I think you've got some thoughts on why or how sometimes compliance requirements can actually lead to less ideal outcomes. Could you just speak to that a little bit?
Yeah, I think it's something that we touched on before is the fact that legislation is lagging behind the actual threat scenario, right? And the attack surface, especially with the introduction of more and more of billions of IoT devices, is just growing larger every year. And so our hacking exploits, they're moving very quickly because they actually don't have to worry about making sure that they're always right. They only have to be right, once, out of 1,000 tries. So they're moving forward very quickly, whereas legislation is lagging behind by sometimes decades, right? And then the compliance regime lags behind that. So the outcome is that when you have a compliance requirement, occasionally what will happen is that compliance requirement is actually an impediment to introducing new technology that would prevent an exploit in the first place. I'll give you an example. When I was, for a while, I was in the aerospace industry, and we had to use chips that were compliant with the requirements of a variety of regulations because they were deemed more reliable because they were compliant with certain rules that were put in place. And those rules were put in place based on a chip design that was about 10 years old, right? So the new, far more reliable chips that could be put in place into spacecraft were not allowed to go in because they were not compliant with the regulations. And so you wind up having a regulation that actually prevented more safety and more reliability because the new technology was not recognized as a solution, which was far better than complying with the stuff that you already know about, which you thought was really safe 10 years ago, but technology's moved on. So recently I was dealing with a project where we were trying to secure some IoT components on a satellite. And they had regulations about cybersecurity for the communications with the satellite. And we have an encryption protocol which does not use any static passwords, right? So our passwords are constantly in flux which is what makes the whole system far more secure than anything with a static password. But it was a cybersecurity requirement for a password that had to be a certain length and a certain size and stored in a certain place, right? Which basically made it impossible for us to use our encryption algorithm because it was non-compliant, even though it was secure, right? So just to give you an example.
Yeah, okay, that's really interesting. All right, thank you for that. And being kind of where we are in terms of real world examples, and I want to start moving towards looking towards the future a little bit. But I know Xander has an example in terms of vulnerability management in particular. How is this done today, and how do you think it's going to evolve in the future, Xander?
So I think I spilled the beans a little bit already by saying like how they do it today, right? Printing it off because it's a real world example where it's from different industries, but there's still a lot of customers who don't do anything at all. A couple months ago, I was in a call with a water treatment facility. They supply water to about 250,000 households in the location in Germany. And I had a meeting with their IT department. There were 3 people behind one laptop. It's like I'm sitting here, but this were 3 people crowded at one screen. I said, it's a nice setting. And they told me, yes, the other 2 people were not able to get their laptop online. So I was still like, okay, why? And then we went to the interaction round. They were from IT. So I was a bit surprised. As somebody who doing security advisories, they asked me, what are security advisories? So there's a lot of people, and this is water industry supplying water to 250,000 households, luckily not at my city. I haven't asked my municipality yet, so I'm not daring to walk in there at the moment. But to put it in mind, so a lot of companies are not doing anything. Other companies are doing it manually, or as I call it, sneaker security. Every time there's a headline, they start running with a USB cable, USB stick, and a laptop under their arm to update everything they see quickly. After 2 days, they lose their interest. So there's not really a standard. And this is, I think, something we need to change in the future with software solution. We need to try to get benefit from all of those nice technologies we talk about right now.
Okay, fantastic, thanks. And in terms of the new technologies that are going to be coming on stream in the next few years, what do you believe are going to be able to deliver? Which ones do you think are going to be able to deliver the biggest benefits in terms of protecting OT networks?
So by looking at it, I think what will help specifically smaller sized companies will be SaaS, software as a service, because you don't really need to invest. You don't have the knowledge to run a solution, to implement something in your factory. You can start easily, so that will definitely be helping. It's also more cost effective as implementing something on site. You can get a quick start. I'd say you can go on a website today, you order it, you can start doing cybersecurity vulnerability management tomorrow. And I think another big role will be played by AI. Imagine you can use AI for repetitive tasks. It's like you have 50 of the same PLCs. You need to figure out if they need to be updated, yes or no. And AI could help you with that. Reading through documents in AI could help you with that kind of stuff. So if I would name 2, those were the 2 I would name as the quickest ones being able to support you.
Okay, so there's new technologies coming on, and obviously AI is going to play a role. But obviously there are going to be new challenges and new threats. And both Ellen and Jack have already talked a little bit. Well, Ellen specifically actually talked a bit about the quantum aspect to this in terms of threats. Then I'll come back to you on that in a minute, Ellen. But Jack, I just wanted to ask you first. What do you believe where are the biggest security threats going to come from in the next 5 or 10 years, and what should companies be doing now to start preparing for them? Is it even possible for them to prepare?
You have to be on this fast-moving treadmill, right, to keep up with everything. Make sure you keep up with the new regulations and some initiatives of your own. And actually, and I think it's something you alluded to, Hamish, earlier on. There is a lack of cybersecurity experts available for companies, and that is something that has to change, because you really have to have people on staff who are doing that full time, right? Because how else do you keep up with the changing landscape? So lack of personnel is definitely an issue. Proliferation of devices that are connected through wireless networks, basically IoT and OT devices that are more and more modern, reflecting the OT world, Industry 4.0 trends, where more and more of the modern infrastructure in critical infrastructure and manufacturing are becoming connected and becoming based on some form of IoT. So proliferation of IoT devices everywhere is going to have a significant impact. Of course, it makes things easier and it makes things more automatic, but at the same time, it introduces a variety of threats. And now the biggest threat that comes from the fact that the attack surface is increasing because of all this automation and digitization of all the industries today. The biggest threat that is potentially the most destructive are bad state actors, right? So nations that have actually that continue to invest in people who will be doing these exploits and who will be attacking critical infrastructure. And it is potentially, a new form of warfare, which is being practiced right now in Ukraine, in the Middle East, and all over the place. So those are the big threats. Also AI, because AI is something that will be adapted more quickly among the bad actors, because they try everything very quickly right away because that's the easiest way to get in. So whatever the methodology that's available today, they will try to leverage that. So AI will be really good at finding 0-day vulnerabilities. So 0 days are the types of attacks that have not been seen before, right? So it's a new vulnerability that you didn't know about is in your software, and it's potentially very hard to find, but AI actually makes it much easier. So AI is actually going to create a more dangerous environment and an easier environment for hackers to exploit. And then there's, of course, quantum computing, right? So quantum computing threatens the most commonly used type of encryption today, which is asymmetric encryption, most commonly known as public key infrastructure, which is a two-key protocol. Unfortunately, that by its very nature is vulnerable to quantum attacks. So the solution is symmetric encryption, but now the problem is what kind of symmetric encryption, and then how do you manage keys? Because public key infrastructure makes it easy. Symmetric types of encryption makes it hard, but it is much more resistant to quantum attacks. And also because a lot of the devices, the IoT devices that will be implemented, especially in smart cities, are small devices with very little computing power, often run on batteries, so they can't really support public key infrastructure encryption in the first place. So how do you deal with those? Can there be a lightweight encryption algorithm that solves the problem? And it's one of the things that we're working on. So I don't know if that answers your question, but it's a plethora of threats and a growing attack surface that you have to try to keep up with.
Yeah, no, absolutely. No, that definitely answers the question, and it's clear that there's an awful lot to do. And so I wanted to come to Ellen now in terms of getting a bit practical, especially in terms of secure and authenticated communication, which is obviously very key in IT. So Ellen, what are some standards and recommendations around implementing from a security and authentication point of view for the whole Industry 4.0 OT environment?
Yes, yeah, I can talk about that. I want to add one comment onto what Jack was just saying.
Yeah, please. Yeah.
Out of our all hands meeting where our CTO called the post-quantum event the Y2Q. So for anyone who went through like Y2K, where we were like all waiting for the year 2000 and all the clocks to click over and everything to break, that's kind of what he was coining this now. It's the Y2Q. We know when it's going to happen. Then we're partnering with IBM because they have obviously the quantum computing power and the they've been working on this for a long time. So it's not a if, it's a when this is going to happen. So I think that's why us in the cybersecurity community, Jack's company, my company, are working on trying to help, because we know that you all that are running factories, running operational environments, machine builders, SIs, like, this is not your expertise, but we are here to help, and we're working constantly to try to stay ahead of these bad actors and these threat actors and these vulnerabilities and weaknesses that we're seeing. So our researchers have been working with NIST to understand these algorithms and implement them into our testing in our labs for years now. So I do feel pretty confident. I do agree about the I think computational power of traditional very small IoT is a little bit of a challenge when it comes to post-quantum certificates that are larger. So we're seeing applications in IoT focused maybe at the gateway level, 1, and then 2 around signing code. So one thing that I think we hinted on a little bit today is just making sure that the firmware that's running in any and all of your ICS systems or devices in the OT environment you have proper code signing practices. I think that's something you can do right away, and you can do with post-quantum. So anyway, I just wanted to make sure to say a little bit on that. And then to your question specifically on, what are we seeing for standards and recommendations? So we mentioned IEC 62443 earlier. There's a lot there when it comes to what IEC, what that standard recommends. But specifically when it comes to what my world and helping get to that SL3 layer and beyond, it's be able to prove with digital identities to verify all these components, and then have a way to manage them. So that's one thing for IEC. I think another thing that we talk about with customers is the IEEE 802.1AR, which defines an IDEV ID, which is initial identity, and an LDEV ID, which is an operational identity. So we work with both OEMs that are creating and initiating birth certificates and birth identities, and then operators that are basically consuming that device and then putting their own operational identity on there. Both are important. Both are used for authentication, also for monitoring firmware, pushing additional features and functionality, and just making sure that your devices are running in a good way. So I think I'm going to pause there, just looking at the time. But those are just a couple of things. We've got a lot more content and things we can share offline, but that's two little bits of info from my world.
Fantastic. Thank you very much for that. And I'm delighted to say that means we do actually have time for some questions, which I completely failed to make time for in my last session. So this is fantastic. I'm going to start off with one which I guess is probably for Sander, because it mentions Siemens. So a question from Damien. Will there be issues for OT equipment manufacturers like Siemens adapting to the Cyber Resilience Act in terms of being able to do that without compromising operational efficiency and equipment stability and reliability? So yeah, will whatever you have to do from a compliance perspective actually end up having a negative impact on operations?
So I'm not sure if I would call it a negative impact coming from a cybersecurity stance. Like we as Siemens have already always taken cybersecurity seriously. I think if you look at all the OT vendors, we are probably the winner in most vulnerabilities disclosed. Not something to be proud of on one hand. On the other hand, we disclosed everything we find, and not only the things people told us they found as well, or they found of them. So I think that's already one of the things we did, which is also a very important part of the CRA stuff. Getting a baseline in there for secure products helps as well, because we also know we might be market leader in Europe when it comes to automation. Not in every area we are that market leader. And also there is never a customer who has 100% Siemens devices and I'd like to be protected on the other end as well. So therefore I think having this standard in place is awesome. We do have established a charter of trust years ago with many other partner companies being in there. looking into CRA. There is work to be done for sure, specifically on some of our older products. We need to look at, is it still possible to fulfill the CRA regulation? So you might see things happening there, but we're taking this very seriously, and I think everyone should do so. And therefore, I hope not only Europe is bringing out CRA, I hope other regions in the world are going to do the same.
Okay, fantastic. All right, so changing gears completely, and this is a little bit of a risk because I'm not sure if any of you have got a strong opinion on this or not, but we've mentioned a couple of times the fact that there's a bit of a talent shortage. And so Dr. Chuck Barlow has asked, how do you ensure cybersecurity college grads have the right fully up-to-date skills and knowledge? Is there anything that you've seen in the market or anything that your organizations are doing to help with that?
I can say one. So we have a really strong developer community. We have some open source product that is basically out there for developers to get their hands around and understand how to use and implement in the laboratory environment. So that's one thing that I'm using is sort of that whole community and people adding to the community. So that's one thing that I'd recommend looking at. So that's how I think we've addressed it.
And then maybe from a Siemens side, so we do support universities. We do have student programs where we have in Europe, for example, people who study and work at the same time, so they get informed as that. We have our own academies. We do support schools and teachers. Years ago, I teach Profinet to the teachers who teach me Profibus. And it was quite funny. 2 years after leaving my university, I was standing in front of a classroom with all of my own teachers in there. So we do a lot of those kind of things, and not just on cybersecurity. It's the whole deal. And we do have special packages as well where you get reduced prices as university to get your hand on newer technologies. So these are the things we do. But check that is really a challenge. And if you have ideas, just reach out.
We're a startup, so we really don't do anything in terms of outreach into the academic world or the industry. We do have some of our software open sourced, and definitely work with the developer communities out there. But that's as far as we can go. But I think cybersecurity, it sounds very complicated, but the basic principles of cybersecurity are not that hard. And so good full stack developers, engineers can pick that up. And if you look at the history of some of the top developers in the world, some of them actually did not have any formal education in computer science, but would be either started out of high school or were university dropouts. So I think you can bring people up to speed once they're inside your organization and you have somebody there who can guide them.
Okay, fantastic. Thank you for that. All right, I have two quite specific technical questions now from Chris Daly. First one is, will NIST IoT labeling, the NIST IoT labeling program for security, have any impact on improving cybersecurity in OT from your perspective?
So
let's do everyone.
I'm not completely sure who should answer that, who's best placed to answer that, to be honest. So
I can give it a shot maybe, because I just checked exactly what was behind it on the site. So I think definitely it will help, because I think it gives you a clearer picture of what's happening with those products. If it's the golden bullet, no, from my point of view, not, because someone needs to read the labels and understand the labels. But I think it makes producers or component producers actually more aware of, hey, these are things I need to think about because I want to have that label on my product. It's like if you want to sell a product in Europe, you need to have a CE logo on your product. And maybe this is helping customers to like, hey, if I want to do an IoT product with software, I want to make sure I'm actually telling customers that I'm doing this the right way. So therefore, I think it's a little bit of it, yes.
Yeah, I agree. Yeah, so like from a smart home perspective, like we did in the US, have these Energy Star labels that would tell people if my appliance is going to save me energy. I think that this should also help in that regard. Well, I'm talking US Cyber Trust Mark right now, but being able to label so consumers can make good decisions about what products to buy and put in their homes. I think similarly from a commercial perspective, being able to have guidelines around this will help. It's a challenge though, I think, to have everyone implement and I think there was some other questions in here about what's the ROI, because part of it is if you're not regulated to do something, then you're going to do the best that you can do, but there's no repercussions. So then it kind of becomes more reactive as opposed to proactive. So I think this is an evolving thing. We've obviously haven't solved it, but I love that we're talking about it. And I love that there's guidelines and standards coming out. And then the ones that are making their way to regulations I think are what's really going to drive the behavior.
Okay. Jack, anything to add on that one? Or?
Well, it's another thing that potentially slows things down a little bit, but you have to have standards, right? So I think NIST certification is a good idea. We, for example, are now in the process of trying to get our encryption algorithm NIST certified. And it's for a startup, it's an expensive proposition. It takes a while to do, which means you're actually creating a little bit of an impediment. But I think it's a necessary one because you do need standards and for the consumer base to understand what is reliable and what isn't. I don't see any other mechanism to do that.
Okay, good. And Chris's second question: could eSIMs be a candidate technology for OT identities? Anyone want to tackle that one?
Yeah, eSIMs, I think they're awesome for my smartwatch, and I think they're awesome for my phone because I don't have to hassle with those tiny cards which break anymore. I think for industry we need something else. I think this is going to be way too complex to handle on a manufacturing shop floor. And imagine having eSIMs, you need to handle them from a global standpoint. You have 5 factories around the world. You already need to deal with your eSIM profiles globally. You're immediately talking about things like that. But the technology behind eSIMs might be very interesting. Like certificate management is, I think, definitely something which is high on the agenda for industrial automation. So technology, yes. The eSIM itself, I think it's too heavily regulated by the GSMA.
Okay, so the answer is perhaps to just adapt the underlying technology for an OT context then.
Right, or use things like, creating, again, in the PKI world, creating a private key within the device based on some entropy and some unique identifier inside the device stored in a and then use that as your root of trust. So different ways to do root of trust, but in a very secure way tied to the asset itself.
All right, fantastic. Well, guys, we're out of time, unfortunately. I'm sure we could all go for another hour, but yeah, we're out of time. So it just remains for me even to thank you to our panelists, first of all, for joining us, and especially to our sponsor, Keyfactor. Without you, these events would not be possible, literally. So we thank you very much for that. I hope the audience has got some great insights. I thought it was a great conversation, and I've certainly learned a lot. And so thank you, everyone, for attending. And that is the end of today's event. We hope you enjoyed it, and we hope to see you at another IoT World event very soon. And otherwise, have a great rest of your day, afternoon, evening, depending on where you are. Thanks very much, and bye for now.
Thanks, everyone.
Thanks, everyone.